All right, I think that's long enough. We can probably get started here. Um, Thank you everyone for joining. This is the last snowpack briefing from the Snow Lab of water year 2025, which officially ends September 30th. But of course, we're melting off much earlier than that. My name is Dr. Andrew Schwartz. I'm the director of the UC Berkeley Central Sierra Snow Lab. Joining me today will be Dr. Gabe Lewis. He is a research and operations hydrologist at CW3E, which is the Center for Western Weather and Water Extremes. Gabe and I had been talking about some things related to the lab, and he created some cool graphics that I thought would work well in here. So a bit of a last minute addition, but happy to do that. So we'll go ahead and get this show on the road. So the first thing that kind of sticks out here on the webpage, of course, is 56.7 degrees Fahrenheit. It is a warm one up here today, may end up being the warmest day of the season so far. And of course, that means that melt is definitely underway here at the lab. Um, we have had about 9 inches of snow in the last week. Of course, that was last weekend. And initially, it was looking like we might get a little bit more this upcoming weekend, but it's not looking too much like the case. Um, Overall, we have made it to above median in terms of our snowfall this season. Our median is just about 360 inches, and we have made it to 363 inches this year, which is fantastic news. So, for the third time in as many years, we are now at average or above average realistically for our snowfall accumulation to match the average that we hit earlier this season with our snow water equivalent. So if we swap our plots here and take a look at our snow water equivalent, we did end up peaking and getting to about 100% on April 1st and the days shortly after that. And then we have had accelerated melt up here since then. The nice thing about this most recent storm that occurred this last weekend was that it gave us a little bit of break in our melt. Otherwise, it was looking like we were probably going to melt out about a week to 10 days potentially early. Which is never ideal. That just means that things are going to dry out faster than we want them to. So that most recent storm cooled things down, gave us some additional snowfall, and then still looks like we might melt out a little bit early, but not quite as much as before. So things are looking pretty favorable there. Um, Right now, of course, you can see here our red line is below the blue line. Early season and late season statistics can be a little bit misleading. We are at 87% of median snow water equivalent to date, but that's just simply because we are melting out quite quickly. Of course, if we go back a few weeks, we were well above median, so it just depends on when we're looking at things, and it helps to keep things in mind when we're examining those. If we come over and look at the weather conditions for the last 24 hours, come on, page. Um, we'll be able to check out what's going on here at the lab. No precipitation, which is shown by this weather type plot in the center of the page. We have had some very warm temperatures. We're already warmer than our maximum yesterday, and are continuing to rise. And overall, winds have been pretty light, staying under 10 miles per hour. And kind of we're seeing, diurnal wind shifts and what are known as adiabatic and katabatic flows. So these are terrain-induced flows that are either going uphill or downhill based off of surface heating of the planet. The big thing that we're seeing here is an increase in our stream height. Normally, this hangs out around 2 to 3 feet. Of course, now that we're in melt season, we're up above 9 feet on a regular basis. We're coming down, but we're already starting to pulse up as today's melt really starts to pick up with that bright sun outside. Uh, this messy looking plot here, black line shows our albedo. which is the amount of reflected radiation from the snow compared to how much is coming in. In fresh snow, it's anywhere from zero point 0.8 to zero point 0.9, and that was the case after this last weekend. It only took about 2.5 days, though, to come back to this lower rate of about 0.53, which means we're seeing accelerated melt in the area. Last week, I did some statistics. We had about 91% of our snowmelt coming from solar radiation, so coming from the sun, and that's on par with what we normally experience here in the Sierra. Warm temperatures and winds accounted for about another 8.5%, and then there is a little bit of melt that occurs from ground heat as well. But the big story here is just that as that albedo decreases and the top of the snow gets darker, we're just going to keep accelerating our melt. Regional snowfall maps looking pretty boring, realistically. Over the last few days, we have had a bit of snow down south, but nothing up here around the lab, despite the wishful thinking over here on Mount Rose. I think that wasn't quite there. That's to be expected. We are here in May, and contrary to popular belief, we do still get snow in May. Our snowiest day with 26 inches was last year in May. So we do still have that happen, just not looking like the case over the next several days. But with that, before I move on to statewide conditions, since we're talking about the snow lab, I'll go ahead and give Dr. Gabe Lewis the floor. Gabe's been working up here at the lab for about 3.5 years or something to that effect, almost as long as I've been working up here, and has been doing various bits of work. So, Gabe, assuming you have permission to share your screen, would you like to take over? I'm going to have to unmute you too, aren't I?
There we go. Thank you, Andrew. Good afternoon, everyone. My name is Gabe Lewis, and I'm a hydrologist at the Center for Western Weather and Water Extremes at UC San Diego. I just wanted to share a few slides about some research that we've been doing up at the Snow Lab, trying to measure the temperature of the snow in order to help forecast short-term flooding when it rains on the snow. So I've been working on a project up there, I think going on 5 years now, Andrew, trying to measure every 10 centimeters what temperature the snowpack is, as well as the soil below that. And this is built on a bunch of previous research by wonderful folks at DRI, people at the Snow Lab. The NRCS has been doing this the last couple years locally, and folks at the Forest Service for a long time. And I've been working up here for quite a while and was able to bring my, I think, 3-month-old at the time when I had to go and download some data or fix something back in November. But what I want to talk about today is the cheese fence, a silly acronym that I spent most of an afternoon coming up with, the Continuous Hydrologic Energy Exchange Snow Experiment, which is memorable, but doesn't really mean much. But here you can see the snow fence in late fall before the big water year 2 years ago. And then in the background of the photo, you can see the towers got a little bit warped after a massive amount of snow fell 2 years ago. And then up above my wife's head in the background, there's a tower that we recently put a distrometer on top of. So that measures if the precipitation is falling as liquid rain or as solid snow or hail or sleet or somewhere in between. And I just wanted to show a few graphics from that, from the Snow Lab this winter. And here we're looking at the temperature of the snow as well as the height of the snow in black. And above the height of the snow, you can see seizure-inducing variation of dark blue colors at night, meaning cold, and red colors, meaning warm. But below that, we've played around with filtering the data, and it doesn't do as good of a job, so we're just plotting all of it. But below that, below the black line, you can see the temperature of the snow as the snow builds up till about April 1st, and then slowly begins to melt, as Andrew was just showing. And really, there were two periods that our snow was pretty cold, was below freezing, which is somewhat rare in the Sierra. In the Central Rockies, you expect snow that's really cold and the ground to freeze. But in the Sierra, the snow stays right about 0 degrees Celsius, and the soil snow interface stays right about freezing typically most of the year. And you can see just before February 1st, the snow actually had some cold content. It was a little bit cold. So I want to zoom in there and show in the top plot here, just zooming in, that the snow was cold till about February 1st, and the snow warmed up as the rain fell on that snow. If any of you were around early February, I was skiing at Palisades, just soaked through Gore-Tex. It was fun with friends, but it was not fun skiing. And you can see in the bottom, our distrometer picked up these blue colors are highlighting that it was raining at the snow lab, as well as a few hours that it got some mixed precipitation, a little bit of hail in there. And one of our instruments that measures the surface temperature of the snow, which typically dives down at night, -10, -15 Celsius, was hovering right around freezing for those 3 days as the rain was falling on the snowpack, really warming up the snow and sopping a bunch of energy out of that snowpack as it transitioned. What do we have? About a meter of snow there from a few degrees below freezing till about freezing for pretty much the rest of the season. So this was a really cool rain on snow event that we were able to measure at the snow lab, which we've been trying to do with mixed success for the last several years. And we're working on some modeling to compare how these high resolution fancy computer models compare with the measurements that we have at the snow lab of transitioning the snow from cold to warm, which leads to a lot of water out the bottom of the snowpack and into the stream that Andrew was just talking about. So we've created these plots, not just for this rain on snow event back then, but for the whole season, which it's a little bit messy looking at the whole season. But you can look at just this last week. I just generated this morning, and you can see that the snowpack is slowly melting out in these purple values, that it's getting below freezing at night, above freezing in the day, and that we were able to capture this snow event last weekend Andrew was just talking about, which in practice meant that we had about a foot of fresh powder up at Mount Rose last weekend for closing day. And as we're entering April, yesterday I was up on Donner Pass helping DWR measure the snow in a t-shirt. Still a lot of snow out there. This is a couple miles away from Andrew, but we were measuring a little bit higher elevation. We were measuring about 60 inches of SWE, so still quite a bit up on Donner Pass at Castle Creek, number 5 DWR snow station. Well, today some colleagues were down by Echo Pass at Tamarack and Phillips and really didn't see any snow there. I don't know what their official measurement is, but from this photo that Devin shared earlier, it looks like about 0 SWE at Tamarack and Phillips. I think Andrew's going to talk about Interstate 80 being pretty much the dividing line north-south of where we got precip this winter and where we did not. But with that, I want to pass it back to Andrew, and you can look forward to more of these plots that will get operationally live on our UC San Diego data share as soon as I can figure out the code to get the cron job to actually do it automatically every day. But it should be this week. I'm working with some smart people that offered to help me out with the coding part of it. So with that, I'd like to thank you all and pass it back to Andrew.
Awesome. Thank you, Gabe. That was fantastic. Yeah, it's been a while. Basically, my entire career here at the lab, the cheese fence has been going in various iterations, and it's great to see what's been going on with it. All right, so continuing on, so we'll talk about the state of the state, what snowpack. But we're going to do it a little bit different than I normally do. There's a new, relatively new page known as Snow Tracks that has been created by the California Department of Water Resources for folks to monitor snow and various other bits of water forecasts a little bit easier. You can find this by going to snow.water.ca.gov. But they're replacing some of the older graphics and things like that with newer, prettier ones. And so if we look here, this is the main page. We can see various numbers. 6.6 is the estimated million acre feet of snow water equivalent as of a few days ago. Approximately 30% of California's fresh water supplied by snowpack, and some other cool statistics. Right now, we also see snowpack as of May 1st, statewide 73%, which is the best. Excuse me, excuse me, 73%. It's not the best, but the northern region is the best at 82%, central at 75, and southern at 54. Like Gabe mentioned, yeah, this year was a year where we had most of our precipitation going up north. I-80 really was the dividing line. Oddly enough, the snow lab hit almost precisely 100%. In fact, I think we did hit exactly 100%, whereas areas to the north of us got more than that, and areas to the south got a lot less. But here we can see that if we look at the entire Sierra Nevada that's outlined here in yellow, or roughly the areas that we are measuring in terms of our water supply, this is what the overall graph looks like, right? Brief 100%. On April 5th, and then a quick melt out. And if we look at things by regional a little bit more, we can see northern region snowpack definitely hit above average. We were up at 122% of normal on April 4th, and that has accelerated in terms of melt over the recent weeks. Central Sierra, Snow Lab is actually very close to the top of this, which is why we hit 100%, even though the rest of the Central Sierra only got to 97% of normal at maximum, 96% of our April 1st number. But Central Sierra closer to average than above average, with the Snow Lab being right at average. And then down here in the Southern Sierra, never really got to average as far as April 1st is concerned. We did briefly get close to our percent of normal here late in March, but then the tap shut off for them a little bit, and we've been melting out pretty quick down there. So that's what we're looking at in terms of the state overall. Another very cool thing, depending on how deep you want to dive into the distribution of water in the state, that you can do is we can come to what's known as the SWE 3D dashboard, or 3D Snow Water Equivalent dashboard, and CCSS stands for the California Cooperative Snow Surveys. So this is going to take a minute to load, but this is actually spatial snow water equivalent in basins that you can come in, manipulate, zoom in on to figure out where snow is still existing in California at the present point in time. So we can zoom out. The cool thing here is we can do this by basin. So the Snow Lab actually borders the Yuba and the American River. So we'll click on the Yuba here on this left panel, and we can see, of course, our snow represented here by blues, greens. As we get to yellows, deeper snow, more snow water equivalent, primarily on the high peaks still in the Yuba. Not surprising, given everything that's going on. We have basin-wide snow water equivalent. And if we look at the American, if it loads here, well, it'll be very similar. As that pops up, I'm going to talk about something. Up here, you'll see this toggle switch. It says ASO, or Ice Snow Ball. ASO is the Airborne Snow Observatory. It's a plane with a LiDAR mounted on the bottom of it that flies these catchments at various times over the course of the year. We can see here in the American, our flight was on April 4th, and this is what this looked like. And that's something to keep in mind. These may not be current conditions, but it's something that you can experience at a slice in time. So April 4th, this is what things were looking like. In the catchments that have more flights in them, let's see here. I think if we go north to the Feather gets quite a few. If we go to the Feather, yeah, the last one was on April 21st, so this is more recent. And we can check out where the distribution of snow is in these mountains as this loads. This is a lot of data. The quality control data from ASO is every 100 meters. It's a 100-meter resolution. The raw data is actually 3 meters. So there's a lot to plot up, which is why this takes a minute. The cool thing about this blue bar at the top is we can look back in time too. So this is April 21st. If we come back here, we can come back to February 25th, get a better idea of what we looked at the end of February after we had that rain that Gabe mentioned, and it'll bring that up. So this is a really useful tool to take a look at the distribution of snow in our mountains, especially on years like this where it's not uniform. It's never exactly uniform anyway, but this year we definitely have a difference in terms of where things are stored. The other thing that I'll quickly show, another cool thing here, is the water supply forecasting resource. This allows anybody to come in here, look at our different basins in the Sierra Nevada, which on the left here. Of course, in terms of color, the grays, blues are going to be better. The reds are going to be worse in terms of our average, our percent of average. And we can click any one of these. Again, we're at the intersection of the Yuba and the American here at the Snow Lab, so I'll click on the Yuba. And this will bring up some really cool information from the entire year. We've got many different forecasts and measurements over the course of the season. First being forecast and how that's changed over time from different organizations, ASO, CW3E that Gabe is a part of, and then we have the CNRFC, the California Nevada River Forecast Center, and then we also have modeled snow water equivalent in millions of acre feet, or maybe modeled and measured, because ASO is in here. But really cool resource for people to check out. I would encourage you to do so. The team, the California Cooperative Snow Surveys Program team, is doing a terrific job of updating this. So definitely look at that. And I wanted to kind of do a show and tell with that, since that's new and shiny and a fun thing to play with. So now that we've talked a little bit about what the statewide picture has looked like, and I've given you some more tools to explore that as much as you want to, we'll move on over to our reservoir levels around the state. And wouldn't you know it, they're looking absolutely fantastic. Based off of this plot, and I know these are a selected number, they're not all of them by any means, but we're sitting in really good shape. And of course, those are recharging as we are using the water in them for various purposes, and we have snow melt running downhill in our streams and rivers. So things are looking quite good around the state with our snow and water resources. As we zoom out to look at the western U.S., this is the SNOTEL network that is run by the Natural Resources Conservation Service, the U.S. Department of Agriculture. Each one of these dots represents a station monitoring the snowpack, and you can see how currently the measurements correspond to what we would want in terms of median snow water equivalent for this date. So dark blues are going to be kind of the happy, greater than 150%. Greens and blues are going to be still pretty ideal. Anything that's yellow, orange, or red is less than favorable. Certainly seeing quite a few reds popping up. Again, something to keep an eye on is just the fact that we are at the end of the season, which means can be a little misleading as things melt out early by a week or two here or there, but still not something we want. If we go back to March, much different picture. And this is the same thing that we've seen all year, realistically, with all these sites. That our driest areas have been in the southern portions of Colorado, Utah, and then also in Arizona and New Mexico. So rather than the individual stations, I'm going to take us to our basin conditions. If this wants to load too, there we go. And make sure that we're at the right date again. That's March. Come to April. There we go. Still quite good around the western U.S. We are starting to see some drier basin conditions emerge along the border of Utah and Nevada. The southern Southern regions are quite dry, other than here in the Little Colorado Basin, which is 97% of its snow water equivalent. But if we look at the entire season for the Little Colorado, that's only recently. And again, this is why, kind of keeping an eye on the bigger picture is a good thing, because if you just looked at that, it looked like it was having a pretty great year, when in all reality, we barely got close to normal and never really got to it at all. So, um, pretty rough year still down south, but looking somewhat good overall throughout the Western U.S. As far as what we're expecting, I'll go ahead and take us to a regional look here throughout the Southwest U.S. and look at what we can expect in terms of precipitation um, over the upcoming next 7 to 10 days or so. What I'm showing you here is a plot of precipitation. Greens, yellows, oranges, those correspond to what you might see on a radar screen, kind of as a artificial radar reflectivity when you're looking at thunderstorms. But the basics of it is light greens are light rain, dark greens and into yellows, and oranges are heavy rain. Purples are a mix of rain and snow, and blues are snow, light blue, light snow, dark blue, heavy snow. So, little few storms here and there today, particularly down south. Um, and then over the next several days, we dry out. Looks like we might have the chance for some storms on Friday and then into Saturday. Pretty minimal precipitation with these storms. It does look like the southern central Sierra or northern southern Sierra, which is confusing, but might get some snow down there compared to the rest of the Sierra, where it's predominantly rain. I chose the European model to look at right now, primarily because we uh, it's got a better handle on temperatures here in the Sierra. The American model tends to have a colder bias to it, so it tends to show snow when we're not getting much. And as such, we trust the European one a little bit more around here. So, uh, see some widespread precipitation really developing on Saturday. Not a ton of snow realistically. That'll move out of the area, and then looks like we might, again, down in the central and southern Sierra, a little bit of snow there Sunday before this system moves out of the area early Monday or late Sunday evening. So that's looking pretty decent. A few storms down in the southern portion of the state, but not anything huge in the ways of precipitation, which is what we would expect for this time of year. So, looking further into the future, as we come to the Climate Prediction Center from the National Weather Service, um, we are looking at the seasonal temperature outlook for May through July here. This was issued 2 weeks ago, just about 2 weeks ago, so there should be another one coming out here in the next few days. Probably won't change much, but it could, so we'll keep an eye on that. But realistically speaking, this is telling us the probability or the percent chance of having above normal or below number temperatures over the next several months. Surprise, surprise. As always, it seems like these days we're looking at above a greater probability of above average temperatures for most of the U.S., especially over the Great Basin and into Northern California. Similarly, it's looking like we're going to be fairly dry across much of the Western U.S., especially in the northern states. It looks like we could have some equal chances down south. I always think that equal chances this time of year, May through July, excuse me, is a little bit funny in terms of precipitation, because the vast majority of our rain and snow comes in the winter months. And so equal chances at regular precipitation really isn't all that great, considering we don't get much anyway. Stepping out and looking instead of May through July at June through August, the above average temperatures take over all of the U.S. in terms of percent chance of that occurring. And that below average precipitation signal looks to shift slightly further north. Again, though, we generally don't get much, if any, precipitation during the June through August month. So, um, not much really that we can be depending on in terms of Mother Nature and water there. Going July through September, more of the same. And then August through October, which is a bit laughable, but more of the same. Um, I can tell you before I get this question, probably not much indication in terms of what we are looking at for next season. It is absolutely remarkable that we have hit average or above average here in the Sierra for 3 years in a row. This is something that only really occurs once about every 25 years or so. The last time it happened was in the late 90s. Before that, it was in the 70s. And so 3 years in a row of average or above average conditions is exceedingly rare and something to be celebrated. Like that's the main takeaway here. I think the caveat to that being we've never really seen 4 wet years in a row, at least here at the Snow Lab. Uh, and that means that even if we were to see a fourth year in a row, drought will be returning sooner than later. The nice thing is that we've had these 3 wonderful wet years to give us a good basis and good storage to prepare with drier years that are likely to be coming sooner than later. But 3 terrific years and a nice cap on this season. We're melting out a little bit early, but otherwise a great snow and water year once again. And with that, I will stop sharing my screen and turn this over for questions if anybody has any. You should be able to unmute yourselves as well. All right.
Dr. Schwartz, Mike Peckner, just curious, does an average snowfall year, especially in the northern Sierra Nevada, guarantee that the reservoirs and lakes will fill, or does it have something to do with something else that I'm not aware of?
I mean, realistic. So, the reservoirs and lakes are already pretty full over the previous years. A lot of prior conditions go into whether or not that can be accomplished. If we're coming out of a long drought period, as we were early in the 2020s, it's going to take probably more than a single year to get us up and full in most of our reservoirs and lakes. But average years definitely help, or above average years. So it really depends on what state the lakes and reservoirs are in, and how big the year actually is. But generally speaking, if we can keep an average snowpack and we've got average reservoir levels, then we're in pretty good shape. I do see a question from Jack Lee. Are there any concerns with snow melting out a bit early? The biggest concern realistically right now, I think for most of us with snow melting out a bit early, is the fact that that means that we have a little bit of extra time for things to dry out before fire season really gets going. Oddly enough, we've already had a fire up here. There was one in South Lake Tahoe, I think it was last week, that got to about an acre and a half before being contained. So, in terms of early melt out, we really want things to stay moist in the ecosystems as long as possible to try to avoid any additional drying. But that's about it at this point. I see another question from Jeffrey Guild. Does having 3 years in a row of above median precipitation make it more or less likely to be above normal next year? That's a very interesting question, Jeff. I hope I can call you Jeff. Jeffrey, yeah, I don't know if we can say it makes it more or less likely. I think statistically speaking, with every additional wet year that we get, it's increasingly likely that we're going to have a dry year. Just simply because, we're not we're not the East Coast or the Pacific Northwest where we regularly get wet conditions year after year after year. We do have these big swings and greater interannual variability back and forth. And so um, I would say it's I would say that based off of the statistics that we've collected up here since 1878, if those are giving us an insight into next year, it's likely to be dry. But as for the mechanisms of that, I can't really tell you. Um, but yeah, that was a really good question. Thank you.
Hi, Andrew. Can you hear me?
Oh, yep. Hi, Ryan. How are you doing?
Yeah, pretty good. So I just wanted to ask, what are some of the technological challenges that you're experiencing when quantifying the snow water equivalent? So it's my understanding that LiDAR aerial surveys being conducted by organizations like the Airborne Snow Observatory are helping, but are challenged to evaluate like wet snow layers versus dry powder layers, which have different snow water equivalents.
Yeah, I think that the biggest challenge right now, and good question, Ryan. Biggest question right now is just or I guess issue is spatial resolution of our direct observations, our in situ observations. In terms of our water resources, we're more interested in the bulk suite anyway. So the various water contents in different layers of the snowpack aren't as big of an issue. Um, and we do have plenty of in situ measurements. We have 260 roughly snow courses around the state. We have about the same number of automated weather stations, most of which have snow pillows. But in terms of when we have the Airborne Snow Observatory flying at that such a high resolution, we're having to do a lot of interpolation between those in situ measurement points because they are so sparse. So it's there's kind of this never-ending rabbit hole of what resolution do we actually need? And
Mhm.
and I think it varies for everybody a little bit. Uh, but I guess zooming out a little bit and getting away from the physical question, the biggest challenge is that roughly 30% of the state's snow courses and I'd have to get this statistic, but I believe the same amount of those automated weather stations are run by federal organizations that are encountering massive uh, reductions in staff. And so,
Mhm.
in terms of the snow courses, we're going to have to make up likely for 80 snow courses that we haven't had to in the past this upcoming year. And that's the major challenge
Wow.
that we're facing right now as I think state water forecasters and state snowpack monitors is just dealing with some of the decisions coming out of DC. We can't really effectively improve upon what we have if what we have is being degraded in front of us. So we're going to have to figure that out before we can move forward. But yeah,
Yeah,
spatial
you
distribution.
segued really well. Okay, you segued really well into like another question that I have. So, I mean, obviously, it's very important for early warning systems to know how much water is sitting up there. So, I was wondering, like, what opportunities exist for UC researchers to support like maintenance and operation of these geodata networks, some of which you mentioned are in jeopardy of losing funding.
Yeah, I think that's a really good question. It's a hard one to answer right now, realistically, because we don't know the extent of the changes that are going to occur. Um, we panicked in April or just before April in March because we thought we were going to have to make up for all of those for the lack of our colleagues doing those snow courses in March. And fortunately, we didn't have to. So it's hard right now. It's a very dynamic situation, and I think a lot of us are looking for the answers to try to come up with. we're looking to come up with answers for all of this stuff, but it's such a dynamic situation that we're not likely to be able to actually act on them for another couple of months. Um, I think at this stage, you know, it's challenging because every basin and every water group manages things a little bit differently. So there's not a black and white answer that I can give you on that. A lot of it's going to be supporting the local organizations when the federal assistance disappears, but that's going to take different shapes for everybody. So a little bit, yeah, it's going to be challenging.
Thank you.
Good question. Thanks, Ryan.
I have another question, Dr. Schwartz.
Yeah, Mike, go ahead.
Um, Looking back over the data, uh, obviously a heavy year or well above normal in terms of snowpack means a later melt in terms of the average of 1 inch or less on the ground at Soda, and a light year of snowfall could mean a earlier melt of the official snowpack. Um, I think you had a figure a couple of years ago that snow on the ground at the lab has melted about 2 weeks earlier than the long term. Is that something that is still true, or is that something that I'm not sure about in terms of how you phrased it?
Yeah, that's a really good question. It really depends, year to year because we have so much annual variability. Um, we have seen an earlier melt out time overall, compared to when the lab was first getting its start in 46 and then the following decades. We're definitely seeing an earlier average melt out. Um, I'd have to dive into the statistics to tell you exactly how early, but a lot of the sites that are in kind of these what we're starting to define as marginal snowpack zones, where we can have these kind of midwinter melt periods and increasingly unstable conditions. Um, they are have been well documented on melting out 1 to 2 weeks early. And each one has different conditions for that. Sometimes that's going to be related to overall temperatures at lower elevations. Um, you know, Stepping outside of the Sierra Nevada, but going into the Wasatch and the Rockies. Um, the increasing dryness in the Great Basin has lofted or allowed for the loft of a lot of dust that sits on that snowpack and then can melt that out easily 1 to 2 weeks early without any additional forcing. So it kind of depends, but it's up here. I would say on average now we're probably melting out the first week of May, um, and that climatologically is much earlier than it used to be. So
Thank you very much. I appreciate it.
absolutely.
I had a quick question as well, for you and for Gabe, maybe. Can you guys hear me? Sorry.
Yeah, we've got you.
Yeah, I was just going to ask about you guys mentioned that you in the past and even recently have had trouble capturing like the rain on snow events using the sensors that you have and then comparing it to the models. I was wondering what kind of like issues you guys face with capturing those kind of events in your sensors.
Yeah, Gabe, I can let you take that one first and then hop on afterwards.
Yeah, sure. It's a really hard problem to try to answer. As everyone on the call knows, snow is very ephemeral and it comes and it goes, and it's really heavy. So, like structural engineering something to measure it is hard. And then trying to measure the rain on snow means you don't want anything vertical that the liquid water can percolate along. So trying to come up with a design that sticks out into the snow and is able to measure the temperature without breaking when that snow consolidates over time and without anything that's running vertical so that water can percolate along. The NRCS has a string of thermistors that they have running vertically, and that's really structurally sound to measure the temperature of the snow. Jeff Anderson locally has put those out at a handful of sites around the Tahoe area. And for just measuring the temperature of the snow, it does a really good job, but might not do as well if it's raining on the snow and rainwater is percolating vertically up and down. So if you're trying to answer that question, that makes it hard. And then other logistical challenges like the power goes out at the snow lab because it is remote and it's not the first priority of the power company to restore it to Andrew and the 6 other people that live up there. And yeah, the snow is heavy, so it broke some of the thermistors during that big water year, or we ran out of storage, or I was living in Las Vegas at the time. and it only rains on the snow a couple times a year, if that. And just some of the thermistors weren't working during the times that it rains on the snow. And in that big year, when it did rain on the snow, it was above the top elevation of our highest thermistors because we had engineered it to be at like the 75th percentile of the max snow height. But that year was much over 100%. Um, so it's a hard problem to do. And other people that are much smarter than me would have probably suggestions. Um, Also, like we bought new towers to rebuild it last summer, but the permit had yet to be signed from the Forest Service to actually dig into the ground to replace the towers. Even though we physically had the towers on site, Andrew had given the thumbs up. We had the funding. There was some just like bureaucratic hurdles to go through. So we're hoping to rebuild it this summer in a bigger and better way with more concrete and stronger steel cables. And uh, it's like 40 different instruments plugged into one CR1000. So we're hoping to do it in a way that is more structurally sound because it's a really hard thing to do. But we're happy with the results that we have so far, given all of the unknowns and uncertainties. So thanks for that question, Colin.
Yeah, I'll pop in to say these are not issues unique to us at the Snow Lab or Gabe's group either. You know, doing monitoring snow during rain on snow events is an increasingly complex and frustrating thing. Um, Energy balance systems, when you're trying to look at the energy being imparted to the snowpack, um, they don't typically work well in wet or freezing conditions. And so, there's some challenges there as well, as far as trying to understand overall what these rain on snow systems are doing to the snowpack and what are the greatest effects on it. Oftentimes we hear about the increased water vapor in the air, the warmer temperatures, meaning greater long wave emission, and that driving temperatures to the snowpack. We hear about deposition because the snow is colder than the moist air, that creating melt in the snowpack. So there's just a lot of weird, kind of complicated things that haven't been resolved in terms of trying to monitor the snowpack when rain's occurring. Cool. I see
Well,
one
thank
hand
you.
up.
Great answer, guys. Thank you. Sorry.
Oh yeah.
Appreciate it.
Thanks, Colin.
Yeah, question from Dick Simpson.
Yep, go
Can
ahead.
you hear me?
Yep.
Yeah, this leads beautifully into a question I've had over the last several years. How exactly do you measure the snowfall at the snow lab? I kind of have this picture of people going out with a ruler at 8:30 in the morning and grabbing a beaker and just sticking the ruler into the beaker and then measuring snow depths to 0.01 inch. I don't think that's how you do it, but I was wondering exactly what the process is.
Dick, you're not so far off, really. So the time is 8 a.m. But other than that, most of what you said is entirely accurate. So we do two measurements every day here when we're getting snowfall events. We do one at 8 a.m. and one at 4 p.m. We go out to what we call the snow board. Sometimes they're called interval boards, but it's ours currently is a piece of plywood with a big metal tube screwed to the middle of it so we can find it when we go back out to do a measurement. But yeah, we take a basic ruler and go out and do measurements of the depth in each of the four quadrants of the new snow. And then we also take a hollow plastic tube that's, depending on how much snow there is, anywhere from 18 inches to a few feet, and take a sample of that snow that we then weigh to get its mass, and that can give us the water equivalent to the new snow. So, when we talk about snow here at the lab, we're primarily interested in its water content and that type of stuff. Once it's on the ground, because that's going into reservoirs. We've actually we're working on publishing a paper with the University of Utah on something called snow to liquid ratio, which is of greater interest to folks. like Caltrans, airport operations, because snow has different densities as it falls. And our data set that we collect every day at 8 a.m. and 4 p.m. is actually really useful for that, because as snow sits on the ground over time, it of course becomes more dense. And so having measurements of it every time it falls before it can really, become more dense is really useful. That was a long answer, but I hope that answered your question. Rulers and tubes.
Yeah, thanks. My picture works.
Ryan, I see you have another question. Would the CSSL be interested in supporting training programs across UC that could train students to assist in snowpack measurements as well as support statewide geodata networks? Yeah, so we actually do this a little bit already. We have a snow school that we do every year in January now, that folks can sign up for. It's kind of aimed more so at late graduate school and early career folks, but anyone's a lot can apply, assuming they and can show us, why they're interested. If you just want to come up and go skiing for free, chances are we won't let you. But if there aren't enough applicants, maybe we will. That being said, yeah, so we're trying to support a lot more of these programs to get people out and about. Again, I think it's hard to determine what we need just yet. I know that when we were looking at potentially having to make up for a lack of our federal colleagues, we started here at the lab. We were organizing people in our Slack channel that had volunteered to do work at the lab and basically treated it kind of the same thing that as the same thing that you're mentioning here is a unique training opportunity, with the ability to go out with one of us from the snow lab, that these students might not otherwise be able to get. Students get the benefit of learning in the field, and the water managers get the benefit of having that snow course done. So absolutely, we're interested in those types of programs and working on them. Coincidentally, I got an email a couple days ago from somebody that attended our snow science school this year, who has implemented those same types of programs that you're asking about, up in Minnesota. Not quite for the same reasons that we have them, but in terms of learning about snow and its importance in hydrology. So, yeah, good question. All right, we got about 6 minutes. So if anybody has anything left that's burning, let us know, and we're happy to chat about it. Otherwise, yeah, it's been a good year, and thank you all for attending. I really appreciate it. Okay.
See you soon, Dr. Schwartz.
Thanks, guys. All right. Well, I guess with that said, nobody else came up to the front, so we'll sign off. Thank you very much for attending. If you have any questions, Gabe and I's email should be publicly accessible from somewhere. If not, you can email us from where you got the link, and we're happy to. I'll be happy to share them. Thank you very much, and Gabe, thank you for your time today too. Have a good one, everyone.
Thank you.